Hello, everybody. This video demo aims to show how we are able to deploy several services using different technologies with the available resources, and how the lack of resources is solved thanks to the CCF that makes use of MetaOS, which uses the whole continuum to obtain resources and keep covering the demand. The deployment of an NS is a process that involves strategic placement, configuration, validation, and monitoring of specific network functions within a subset of computing resources. Our demonstrator consists of a management and orchestration framework, MLF, whose main purpose is to provide scalable, distributed, and AI-driven orchestration for service management, and a Cloud Continuum Framework, CCF, which enables a seamless aggregate management for distributed compute resources. The demonstrator will build upon a set of data centers located in different places and composed by different domains, using physical and virtualization technologies. On the hand, we have the RAN domain and the core domain, and on the other hand, Meteos domain using the framework Fluidos. The RAN domain has specific hardware to provide TUE's coverage, as shown in the pictures. And the underlying technology to deploy request services is using OSM with a VM of OpenStack. The core domain, connected to RAN domain, provides services with a higher level of compute. The NF vMano available in this architecture is a Kubernetes. And the last domain. Meteos takes advantage of all the resources of the continuum to always have an availability either to deploy or offer resources. In order to take advantage of this, Meteos makes use of the framework Fluidos, in which the University of Murcia has collaborated in its development. In this case, we have two independent Kubernetes clusters in two different locations and on different networks. Using Fluidos, we can acquire parts of the resources of a cluster to bring it to us and make use of it. The process starts when a network operator requests to the MOF component, asking to deploy three services: a front-end closer to user, a backend, and database where the data is stored in Spain. To do this, the operators send an intent. This intent contains the different information which will be sent to the MLF. If we take a look to the policy, the intent/policy contains three services. The first one asks to deploy a frontend called Meteos frontend, with a hard constraint of latency less than 3 milliseconds. The second one asks to deploy an app called Meteos backend, which requests a machine with a core CPU greater than 1. And the last one asks to deploy a database with a location have to be in Spain for privacy, and a storage of disk greater than 50 gigas. Once the MOF receives the intent, it communicates with the CCF, as the CCF will be the one to provide a list of options that best fit the current scenario, the most suitable nodes to deploy the different services. Therefore, the CCF presents the three different domains. But the intent cannot be allocated in a single domain or data center due to their constraints. Hence, the MLF decides to select the option which involved to split the policy into three and send to the different orchestrators of the different domains a lower-level policy. We will see a real interaction of this process. Here we're watching how we send the policy, and the MOF obtain the answer of the CCF. The service orchestration decide to split the intent in three and transform from high-level policy intent in a lower-level policy intent. As you can see, the MOF has edited the intent, including the domain, where the intent part will be sent. The domain ID 2 corresponds to the RAN domain. The domain ID 1 corresponds to the core domain. And the domain ID 3 corresponds to the Meteos. Now we will see the different orchestrators' terminals from the different domains. In the bottom left, we have the RAN domain. As we mentioned before, the vMano is OSM with OpenStack VM. That means here we will deploy virtual machines, not container. Here we will deploy the frontend. In the bottom right, we have the core domain. The NF vMano here is Kubernetes, and we will deploy the backend. And the top right terminal corresponds to the Fluidos framework, giving us the possibility to use the MetaOS. Here we will deploy the database. Now, the intent arrives at the different orchestrators, and the orchestration process begins. This process goes through multiple phases. The first step is to decide which algorithm is necessary to orchestrate the intent. The AI-based meta orchestrator determines the most suitable algorithm. Once this is decided, The next step is to determine the allocation action. In this case, a new deployment of the service is required, but it could also involve only a configuration update or a service migration. As seen in the red box, the deployment will use ILP as the orchestration algorithm, with a hard constraint requiring latency to be less than 3 milliseconds. For the core domain, the decisions remain the same. A new NFV allocation will be performed using ILP, with a hard constraint specified by the backend requirements, which demand a core CPU greater than 1. In the Meta OS, there is a difference. The orchestration algorithm is based on ant colony optimization. This choice is made because, when dealing with a large number of nodes, ant colony optimization can make decisions faster than ILP. The orchestration algorithms will determine the enabler to be deployed and the most suitable node within the architecture. Once decided, the enforcement process will begin. In the case of the RAN domain, we can see that the algorithm has determined the node where it will be deployed. In this case, it uses the OpenStack VM under OSM. To achieve this, it has identified the necessary descriptor and the deployment process begins. As shown, if we access the OSM interface, the network descriptor instance is running. In the terminal of core domain, we can see that the process has found a candidate and, making use of Helm chart proceed to deploy the enabler. If we check the Kubernetes dashboard, we will see a new namespace. And in that namespace, if we go in, we can see the deployment. The last case, in the Meteos, the orchestration process is showing that there is not candidates, so it's going to trigger the Resource Acquisition Manager in order to obtain resources to be able to meet with the requirements of the intent. For this purpose, the orchestrator create a request in JSON format asking for a resource that meet with the constraints. Right now, the domains are busy deploying and searching for resources out across the continuum. Now the Meteos has found a candidate. Therefore, now we can proceed with the next step, which is perform the reservation and purchase of that resource. To make the reservation, it is necessary to fill in all the data in JSON format and send it to the Resource Acquisition Manager to proceed to make use of the resource. In the meantime, we can see how the core domain has finished deploying the service. And subsequently, the RAN domain has also finished deploying the service. We can confirm it in OSM interface. On the other hand, making use of the Fluidos framework, we are connecting the resources that we have acquired to have it locally. To do this, we establish a peering using the Lico tool. Once the peering is established, we proceed to use those resources deploying the service. The underlying technology is Kubernetes, so we use Helm chart to deploy, in this case, the MySQL database. Once deployed, we have our set of services ready. We can go to front end and see that everything is working. With this, we have demonstrated that the system is not only capable of fulfilling the intent by taking advantage of the resources it has, but by taking advantage of the whole continuum, what we would call Meta OS. We are able to offer services when we do not have resources or the resources are limited. Thank you very much.